G'day, my name is William Brown. I'm a senior software engineer at SUSE Labs. I've been part of the 389 Directory Server core team for the last 5 years. Today we're going to be discussing the process and what exists to help support you in your migration from OpenLDAP2 to 389 Directory Server. So let's discuss some of the advantages of 389. One of the first things that people notice when using 389 is the attention that has been paid into usability. As a project, we've put a lot of effort into our administration tooling and making that accessible and easy to use, because we understand that LDAP servers tend to be very large, and the more accessible and easier we can make it for you to do your job as an administrator, the better experience you're going to have and the better outcomes you're going to have. The project is very feature rich. We have a large number of schemas and plugins available by default, and this makes it very adaptable into various situations and circumstances that are going to meet the needs of your organization. 389 is also very scalable. When we say scalable, we don't mean as much about individual single server performance. We're talking more about treating 389 as a replicated topology, where you have many servers in a replication group. We are capable of databases of multi-millions of entries, and we are also capable of planetary scale replication, where some of the largest deployments in the world include up to 1,000 servers in replication groups, though I certainly don't advise you to do that without a lot of planning. Generally though, our horizontal scalability is extremely good in terms of being able to adapt to load. The project is also well known for reliability and security, and this just comes from not only the engineering teams and the attention to detail and the high quality of the QA teams that have been involved from many companies, but also the fact that as a project we have a very extensive test suite, and we actually run the entire system through various memory safety sanitizers to ensure that the code that we're producing is always the best that we can and doesn't have memory leaks or buffer overflows or things like that. It's well known that 389 often can run for long periods of time without any kind of outages or restarts required. So 389 is going to become the default and only LDAP server available within SUSE. I am not willing to confirm which version that this support will be removed in, as I think that is still a question that's up in the air. But certainly 389 support was first really introduced properly in SLE 15 Service Pack 2. A lot of the features we're going to be talking about today, however, were introduced in SLE 15 SP3. And this gives us an overlap of time where both OpenLDAP2 server and 389 Directory Server are supported in the distribution, giving you time to plan and perform the migration. So let's look at some of the differences and similarities between OpenLDAP2 and 389DS. One of the first things that you're likely to notice as an administrator is that the way you approach configuration is different. OpenLDAP has had two configuration formats: slapd.conf, which is a static single file, and the slap.d directory, which is a dynamic configuration, but it can only be updated by the specific LDAP tools that exist for that. 389 Directory Server is a little bit different. We have a completely dynamic configuration, very similar to slap.d, which can run from the cnconfig partition. However, when the server is offline, this is stored into a single LDIF file called dsc.ldif, which you can edit and you can modify if required. So there are many ways that you can approach configuring 389, from file management to dynamic configuration. In terms of LDAP schema, OpenLDAP ships with a number of schemas, but the default installs tend to use a minimal number of these out of the box. 389 Directory Server, however, we also ship many of the same RFC compliant schemas as OpenLDAP, but we enable many more of them out of the box, meaning that we are very likely to support these schemas that you require for your organization. Both OpenLDAP and 389 support customized schema. They use a slightly different format, but part of the work that we have done at SUSE is to help automate this migration to convert between these formats for you. Both of them support the LDAP database, LDIFs, the LDAP searching, all of those things. They're both protocol compliant LDAP servers, which means that for the majority of clients, they should be able to move between 389 and OpenLDAP with very little difficulty. Replication is probably one of the ones where OpenLDAP and 389 really diverge. OpenLDAP uses a protocol called sync-repl, or alternately delta sync-repl. 389 uses its own replication protocol called NSDS5. Both of these work in slightly different ways, and the main way that this becomes apparent is in the replication conflict model. Now, because both servers attempt to achieve an eventually consistent replication topology, which is where you can have many servers that are all active and receiving writes, and then eventually they will replicate and send each other the data. What this means is that when the replication occurs, we need to be able to deal with what's happened if an entry is added on two servers, and then we have to deal with that conflict, for example. OpenLDAP manages replications and its conflicts by doing at a whole object level, which means if you change an attribute on object A on one server and you change a different attribute on the same object on a different server, only one of those changes will persist because the whole object will either win out over the other one based on the order of time. 389 Directory Server, on the other hand, has attribute-based replication. And what this means is that if you have, say, a multi-valued attribute, we can merge those two lists even if they are both changed on different servers. And this allows a much richer and much more confidence in terms of distributing writes across multiple servers. Both of these have read-only replication. Both of them are supported for this. 389 also has a number of features in terms of having intermediate transport hubs for replication to different locations. Both have the capability to have their features extended. OpenLDAP calls these overlays, 389 Directory Server calls these plugins. Functionally, they're very similar and really achieve the same kind of things. TOTP. OpenLDAP supports this in its upstream versions, however no version of OpenLDAP in SLE has supported TOTP. Similar, 389 also does not support TOTP. Entry UUID is supported on OpenLDAP, and it's supported as part of 389 from 15 SP3 and higher. Entry UUID is commonly used by a number of applications to act as a foreign key, so that one that comes to mind is VMware requires entry UUID on LDAP entries in order for it to create foreign keys to its internal database. Plugins are very, very similar. For example, things like MemberOf, referential integrity, and attribute uniqueness are all supported between OpenLDAP and 389. There's differences between these, of course, in the way that they are configured and some of the more advanced use cases that may exist between them. But for the majority of use cases, all of these are supported. Access controls is another area where divergence is very large. OpenLDAP has static access controls, which are part of the configuration, and these tend to just be part of that config per server, which means that you can have access controls that are different per server. Whereas in 389DS, they're dynamic and they're part of the database itself, meaning that not only are they also replicated, but they have a different syntax and a different language for those access controls. LDAP proxying is supported in OpenLDAP, but it is not really in 389. We have a different plugin called chaining, which allows effectively routing and proxying a query, but it doesn't work quite the same way as the LDAP proxy functionality in OpenLDAP. So this may be an area that you need to investigate if you're using this. OpenLDAP does not have Active Directory synchronization capability, and generally it would be advised that you would use the OpenLDAP proxying support. However, 389 does have Active Directory synchronization, where 389 is able to read from an Active Directory domain and then import accounts and some password details if requested, meaning that you can synchronize that content into 389. In terms of hashing algorithms, so for password storage, OpenLDAP supports only its own hashing types. It doesn't have any of the hashes that 389 has. 389 supports both its own and the OpenLDAP hash types, which means that you should not need to rehash passwords in the process of migrating to 389. And of course, these are all high quality salted key derivation functions, things like PBKDF2 and Argon and things like that. For external authentication, if you want a different authentication provider rather than using the username and password support that 389 and OpenLDAP have natively, OpenLDAP uses SASL authd as an external auth mechanism, whereas 389 would use a plugin called pass-through auth, which calls out to PAM, and that may call a different module like PAM Kerberos or perhaps SSSD to do the external authentication as required. And of course, in terms of dynamic attribute generation, both OpenLDAP and 389 support this, but they use project-specific mechanisms for it, again, meaning that there will have to be investigation and research to determine how your different templates need to be migrated across. So something that I hope is really clear here is that not only are there many similarities between the projects in what they offer to clients, but they're also not equivalent. The features that are internal are slightly different, sometimes very divergent, but otherwise, they're both offering LDAP and clients should still be able to talk to them. In this process, we assume that the migration is one way. We are only providing tooling and support for going from OpenLDAP to 389. Going from 389 back to OpenLDAP, however, is not something that we've covered, and we will discuss this shortly in how we're going to approach the migration to help avoid this as a conflict area. 389 certainly brings a lot of new and different approaches to the way that you administer an LDAP server, and that means that, of course, this leads to the fact that research and planning for your migration will be required, and that's why there is an overlap window where both of these will be supported, and that way we can, if there are unknown issues or things like that that require support and assistance to enable you to perform that migration, we've got time to be able to have those discussions and to put in that work to devise solutions. So let's have a look at some typical OpenLDAP 2 deployments that may be seen or you may have in your environment. If you're a small environment, you may have a single read-write server directly attached to your clients. This might be a very small office or something like that. You may have multiple read-write servers with replication, and you have your clients directly connecting again. Or, as you start to grow, you may have many clients connecting to load balancers, and then those load balancers are proxying through to a pair or multiple read-write servers, again in a topology. This is the kind of area where we're starting to see maybe like a medium to large size university and what kind of management they're doing for their infrastructure at this level. Finally, some very large deployments, especially over large geographical areas and multiple countries, may have multiple read-write servers at the top of the topology, which distribute to a set of read-only servers, and then different load balancers per area, and then the clients of that area going to their localized load balancer. So this is a much larger topology, and again will require a lot of thought and planning to how you perform a migration in this. And something that is really interesting about the way that people tend to use OpenLDAP is that because it's a box of parts and there's many ways to assemble them, there's no real wrong way to do it. Every deployment, every install ends up being very custom and different to the last one, which means we can't make assumptions around what your deployment will look like because it's very likely to be unique. This caused us to have some interesting goals that we needed to meet with any supporting tooling that we have to help you automate the process of OpenLDAP moving to directory server. One of the key things is that we must not interfere with production. Your production OpenLDAP server must continue to work during this process. It should not be bogged down or loaded or have any risk of it going down. LDAP is critical to your business, and so we made it our goal that we must not interfere with production. We wanted to design a tool that encouraged you to have confidence in your ability to repeat the migration process without damaging your production environment, so that you had time to do research, do testing, and to build your own confidence that the migration was going to be successful, and to allow other units within your business to do testing and acceptance of the new infrastructure in parallel. And of course, we decided that we wanted to try and automate as much as we could, and advise about what we could not. So there's a lot of things that we can automate in this migration, but there are things that we cannot. So let's have a look at the high-level process of what a migration might look like. Let's just assume one of these topologies that we talked about before, but realistically, the process is going to be very similar for all of them. The first thing that we do is we take a backup of one of the read-write servers. We only need one of them. We just need its slap.d config, which is the dynamic version, and we need an LDIF backup. If you're using the static config slapd.conf, it's possible to convert this offline and on a different machine from slapd.conf to the slapd.d config, and this is documented what that process is. So you don't have to adopt the slapd.config if you want, it's just that that's what we need to do this migration. From this backup, this can be transferred to another machine, completely separate. This could be a test machine, staging environment, or your new production machine. These backups are fed to the tool called OpenLDAP2, which will advise, give you some information, and then given an existing instance of 389, it will configure it to match in line with what the existing slapd config and the LDIF backup have within them. It'll even import your database and do some of the needed data changes. It'll import Schema and a few other things. Once this is done, you now have a 389 instance, which has a copy of your production data and a reasonable looking config. You'll probably need to still make changes at this point in order to bring that new 389 read-write server in line with what you expect. But once you've done this, you can begin to build your 389 replication topology in parallel, and you can begin to set up a new load balancer, for example. You can begin to drain clients from OpenLDAP over to the 389 instances. At this point, if you have a fault, this is where you can roll back very easily to the original OpenLDAP instances, because this way if something unforeseen happens, because we haven't altered, changed, or destroyed anything in your OpenLDAP environment, you have a very clear rollback path to just cut back to the previous load balancer. So this is where things like lowering your DNS TTLs before you start the migration is very important. Provided that you're happy with this, and all of your clients have moved over, you may have some window of time where you run these in parallel, and maybe an external data source is feeding in account changes or things like that from an IDM to both of these. And then at some point, once you are confident that you no longer need the OpenLDAP infrastructure, it can be removed and you'll fully be on the 389 infrastructure that you've built in parallel. The key part of this process here is this step where we do the first data migration and conversion through the OpenLDAP2 tool. What it does, by default we take no actions. We only advise on what we will do. What it does is it parses your slapd config and the LDIF database that you have. It will generate a migration plan for you to review. If you accept it, you will rerun the tool and the migration steps are applied to the 389 DS instance. And we even create a post-migration task checklist of things that you should then go and follow up. And of course, after you've generated and followed this checklist, you can document the steps you've taken, keep these, and then reapply that migration and then redo the steps, for example. So like the workflow here could be that when you first do this in development, it may take you a while to set up, okay, here's the access controls I need, here's what I need to do. But as you're documenting these, this can be scripted. This means that every single time you're doing this migration, it can be easier and easier for you to do this post-migration tasks. And then that will give you a lot of confidence that when it comes to production, you'll be able to do those tasks given that you've already done it and done the research that was required. So let's do a demonstration of what it looks like to do this migration and some of the other administration elements as just a bit of an introduction to 389. This certainly is not going to be a complete overview of 389's administration capabilities, but certainly it should help to get you introduced. Things that we would normally need to do on any new system to be able to perform this is to install the packages we need. We'll need the 389 directory server as well as the OpenLDAP2 client tools. I've prepared this machine earlier, so I'm just going to skip this, but you'll need to install this for yourself. When we have a look at these what's been installed here, and we look at the output of the RPM listing, you'll see there's a number of tools that have come with this, and a lot of schemas and things like that. So let's go ahead and introduce the tools that we are going to be using. So one of the first things that we're going to use is dscreate. dscreate is what makes a new instance. Now, OpenLDAP only supports one LDAP server per machine. 389 allows you to have many LDAP servers per machine, and each LDAP server can have many backends attached, just like OpenLDAP. We call these instances. So if we have a look at the dscreate options, this is really well documented, and there's many things that we can do. We can create a template file, which shows us what options we could use to configure our new setup. This file is extensively commented, and I would advise that, if you're doing this, then you can read through this, but many of the settings are quite good defaults. One of the ones that's very important for you to be aware of is instance name. This is what is going to determine the name of the instance we're about to create. The port that it will listen on, again, only one server can listen per port, so if you have many instances, you'll need to work out which ports the alternate instances will listen on. The root password, or the password for the CN equals directory manager account. This is equivalent to the root user, but for the LDAP server to manage the CN equals config partition. Whether we generate and add a self-signed certificate, generally leave this as true, and this can be replaced later. And whether you want to create a default database. By default it's no, but if you actually enable this to be true, and you add the sample entries and set up the suffix name, then it will create the example database. So I've already created one of these files earlier. You can just redirect the output of the create template into a file like I have here, and we can see that we've set up the options for our instance. We don't install a default backend, and I would highly advise that you use a significantly better password than I'm using for this demonstration. I'm only doing it because it's easy to type. So we're going to create our instance now, and we're going to use the from file option, which is what's going to read our options that we've just configured in our file, and this is actually going to do the work. If you want more logging, you can add the -v flag. It will begin the setup. And during this process, what's happening is that it's setting up a number of plugins, it's creating the configs, and it's applying the settings that we have, and it's now complete. So we can now see our instance, and they're named as dirserv at instance name. And often in documentation that you'll see from SUSE and others, you'll often see this referred to as the instance name or instance here or something like that. This is where you need to put in that instance name that you configured. So if we have a look, we can see that our instance is now active and running. If you wanted to, you can now enable it so that it will start on boot. Now that we've done this, we can also show that it's actually working as well. So we can search localhost BS base, and we can see that we do get a correct response from the server, and if we request the extended attributes, we can see that it is indeed 389 directory server, and what supported controls, extensions, and other things exist within this instance. So we now have a working 389 directory server instance. If you're doing a just new install, at this point, you would use things like dsconf and dsidm, which are other tools for managing the configuration and the backend content in order to set up your database. But if we're doing a migration, at this point, we now need to look at what the migration steps are. I've taken a backup of an OpenLDAP server and placed it into /root OpenLDAP here. This instance has two backends, and I've exported both of these into LDIF files, and we also have the slap.d dynamic configuration. If we look at the OpenLDAP to DS tool, and we look at its help, this is very extensive, and it has a lot of information and support about what is the process that you'll need to take, what are the things that are migrated, what cannot, and also steps, things like what content you should back up and how to back it up in a way that's not going to interfere with your running production instance, as well as how to do the conversions of the slapd.conf into the dynamic slap.d folder that we require for the OpenLDAP tool to actually work. We also give some demonstrations around what is the correct method for generating the backups that we need for importing. The way that this tool works is we'll take, on one side, we take the instance that we want to migrate into, and then on the other, we begin to take the options. So if we go openldap2 ds localhost, which is the name of our instance that we created before, and then we send in the path of the OpenLDAP slapd location, which is our configuration, and then we can give an arbitrary list of all of the backend LDIFs that we exported that we want to import into this instance. These don't require an order. These will be examined, and the migration tool will work out which data goes to which backend and what goes where. So if we run this now, you can see that a lot of output has happened. It has examined the OpenLDAP config, and it examines these databases, and it describes exactly what steps we're going to take. If you have customized schema and it was in your configuration, that becomes part of the slapd config, and this process will automatically migrate this for you. So you can see that there's a number of schema elements that are going to be brought in, such as the SUSE custom schemas that are provided by YAST, and some of the other object classes that we need to support. It'll also tell you what things are unsupported as attributes, because maybe this attribute syntax does not exist on 389. There's only a handful of these, but these tend to be very esoteric types. So it's unlikely that this will cause a problem, but again, if it does, please contact support. We then see that we'll create a database which is based on our suffix name. We're going to add indexes that existed in OpenLDAP, and it will perform a reindex to make sure these are updated. What plugins we update and enable based on the configuration from slap.d, and also again, we then create the second database for the second suffix we're importing, and we also configured the plugins that relate only to that suffix again to ensure that they're enforcing the attributes and does all the fix-ups and things. And then finally, it actually does the data import. And as we can see, no actions were taken to apply this use -- confirm. So we're going to confirm this, and the migration will begin. And it begins to print out the list of steps and what stage it's up to. Again, if you request the verbose options, you'll get a lot more output about what is going on. And after all of this is done, we've now completed. This exception, I apologize for this. The upstream tool uses an emoji here. It's not actually an error. It's just that it can't be printed. Everything else is fine and the migration is good. So, as mentioned, a checklist is provided at the end of this operation that you can follow. And it's even helpfully formatted so you can go and actually check off the items as you do it. And this is things like you need to check your access controls, verify and check TLS, which is essentially the root of trust for LDAP. Set up your backups, verify that you can log in and bind, review your plugin configurations that we migrated, and then check fix-up tasks and things like that that need to be run to ensure that all the data is consistent. So let's go through a little bit of some post-configuration. This is going to be addressing some of the things in that checklist. Some of them we're not going to address today just because of time constraints, but we'll go through a few things that are going to help make your life a bit easier. So the first thing is that there are, as mentioned, dscreate creates the instance, openldap2 migrates it. There are 3 other tools that are used to manage an instance: dsctl, dsconf, and dsidm. Each of these learns how to connect to that instance from a file in your home directory called .dsrc. So if I go into my root's home directory and I look at the dsrc file, I've configured it earlier. What you do is you provide the name of your instance, the URI, the base DN of your database that you want to be using, assuming that there's one, and the name of the account that you want to bind as. This doesn't always have to be CN Directory Manager. This could be, for example, this could be an ordinary user who just wants to change their own password or something like that. So this can use URIs that are not just LDAP or whatever, but one thing to note about the LDAP I socket, which is the localhost Unix socket, is that it does use file permissions and your running user ID process. So if you're running as the root user or the same user as the running LDAP server, which is DServ, then you implicitly become directory manager without a password, because physical access to this machine is considered to be game over anyway. So this means that what we can do is with our dsconf command, we can now look at our instance and we can list what backends exist. And we can see that it has successfully imported DC example DCComp, DC example DCNet. So DSCTL is what does actions that generally require root. This generally requires you to be on the machine as root because you have to manipulate file system, you're doing backup, starting process, restoring, things like that. There's a lot of commands here. Again, all of these are extensively documented, have extensive help options, and can really help you out. Two of my favorites in this, however, are the TLS subcommand, which can help you manage TLS certs, and the health check command, which can tell you a lot of information about your directory server and things that may help it become more secure or things that maybe are misconfigured. An example of the TLS command that's really cool though is that you can list all your CAs, you can generate CSRs, you can import certs, server keys, all of this stuff. So there's a lot of stuff here that's going to help make configuring TLS for your instance really easy. dsconf is about managing the content of that cn config or that dse.ldiff that I mentioned before. This does things that generally require directory manager. So you can be on a remote machine, that's fine, but you generally will need directory manager for this to work. Again, there are extensive amounts of help here, and you can manage many things. Backends, backups, you can do online backups, so you can do that. There is chaining, configuration, managing the directory manager account, monitoring, different stuff to do with replication agreements, security, and of course under plugin, there's a large number of plugin options that can be checked as well. So, you know, the kind of plugins we have like MemberOf, AutoMember, Referential Integrity, USN, Account Policy, and so many more. There's a lot of things that these tools are going to help make accessible to you. The last one is the DSIDM tool. And DSIDM is about managing the content of a database or a backend. And this is generally about managing accounts or groups or users or things like that. And so, you know, let's go and have a look at doing some of this stuff. So one of the first things that we can do to just make our life a little bit easier is we want to be able to do LDAP searches. And when we go to do LDAP searches, as we saw before, I had to type in a large number of options for this search to work, like -H, -B, -S, all of that stuff. From DSIDM, we can actually help generate and see some of the options that may help us have a better experience here. So if we go DSIDM localhost client config, DSIDM has a number of sub areas where it can help you by displaying client configuration options. It can generate SSSD comps, the LDAP comp for your Etsy OpenLDAP, just for the LDAP search commands, but it can also just display generic parameters about your instance that maybe you can plug into like a web application or things like that, that is going to make it a bit easier for you to actually configure applications to join this. So let's have a look at what the LDAP.conf shows us. And this generates it. It shows us what our base DN is for this instance. This is retrieved from DSRC. The URI, again, this is from our DSRC, but we could change this over to be the host name, where our TLS certificates probably are, and things like that. So what we can do is we can actually echo this into Etsy OpenLDAP.conf. Then we're going to edit that just to, in this case, I'm just going to fix it up just so that it uses TCP/IP instead. And if I do LDAP search now with -X, sorry, I should have done. We're now connecting to the same instance And you can see that I didn't have to add all the host names and other things in. One of the first things, though, that we're going to see now is that, as you probably saw here with LDAP search-x, we're requesting the content of DC example DC.com, but we get no results. But our data is there. If we actually do this, but with our cn equals directory manager, you can see that all of our entries are there and they were successfully imported. The reason for this is that by default, when we're importing this database, because there are no access controls in this database, because the access controls are different, we default to deny all. This means that as soon as you do your import, it's probably going to look like your data is not there. It is, we did import it, it's just that the access controls need to be set up. Access controls are probably one of the more tricky parts of 389, and we're certainly looking at adding in some tooling and some supporting material to really help make this easier. The access control syntax is the ACIs are placed onto the entries themselves, and they apply to that entry and all child entries. So this ACI placed at DC example affects the entire directory. And for example, it says, to these target attributes like object class, description, DC, and on this class of object which matches that filter, allow read, search, and compare to anyone based on their LDAP URL. And you know, this could actually name a specific user, or there could be a group DN, so you're naming a specific group. And so you can actually use these very flexibly to even do things like group permission delegations and things like that, which is really cool. Again, for example, this OU groups rule will only apply to groups that exist under this OU. If you have a group that's outside of this OU, this rule won't apply. And again, you have that same format, targeting what attributes and what filter are being acted over, and then what rules are allowed and who is allowed to perform them. Again, very similar with people here. So we can apply this. With the standard LDAP tools that we have. And don't need that actually. So we apply our access controls now, and if we were to repeat our search as anonymous, we can now see information about groups, people, and our base entries and our OUs. Again, it's worth noting that because of the rules that we have, there may be some things that we can or cannot see here in this. So what we can do now is we can now attempt to check whether our counts can bind correctly. With DSIDM, it's worth noting that there are two commands that really look at accounts. You have user and account. Users are specifically set up to match a certain set of object classes. So when we do user get right now, we're not going to see anything. So if we do user list against our instance, we'll see nothing. And it's not because there aren't users. It's because there aren't users that are set up as NS users, which is the Netscape schema name given the historical origin of the 389 project. So because we don't have any users with this object class, this is why there's no users being listed. But this is where the account command steps in. The account command acts on all possible entries that can bind or could bind to the directory. So if we've got account list now, we can see our people. Now I know you might be asking at this point, why have you got your DC object, the OUs, and the CN groups? This is because it's actually completely valid within the LDAP standard for groups, OUs, and domain component entries to hold a user password and be able to bind. That's why they're listed here. So it's not a mistake. These things can actually bind if a user password was set against them. So one of the first things that we can do now is we can actually set up one of our accounts to have their password set. So if we go localhost account, reset password, and we can now set up a password on the account. Done. Now we can actually do a LDAP who am I with this, and we've now successfully bound to the directory. If you did have user passwords already on entries that were migrated in, this is the time when you want to check that they still bind. They should. We do have support for the OpenLDAP hashes. You should not need to do any rehashing. Accounts should still work when you bring them over. The next one that's often requested and asked about is MemberOf. MemberOf is a plugin that does reverse attribute generation. It basically says, rather than a group saying, here are my members, that data can then be used for every user to say, I'm the user, I'm a member of these groups, and it allows applications like SSSD and PEM-LDAP and things like that to have a much faster lookup because they only need to look up the one user to understand what their group memberships are. They don't need to look up every possible group and do a lot more complexity in searching. So MemberOf is a really common and very useful plugin, and actually it works very well with ACIs. So you can tie in filters that say, okay, people that are member of this group can do this permission, for example, which is a really powerful thing. So again, in our task list, we could see that things like reviewing the MemberOf plugin configuration was correct. This is where dsconf steps in. dsconf, as mentioned, is about configuring the instance. So this is where we can configure that plugin. So we can have a look at the set of plugins that could exist, but specifically here, we're going to look at MemberOf. And we can see that there's quite a few options here. We can show its current configuration, for example, and we can see that the plugin has been enabled and it's acting over DC example, DC net, and DC example, DC com, which is exactly what we expected because when we did the import, the migration tool said, yep, we're going to import MemberOf from OpenLDAP and have it still work on these backends. Because of the way that the migration works, we just need to quickly do a restart of the instance, but there is an update coming that will automatically do this, so you don't need to do this manually. This just has to do with the enabling of the plugin, doesn't take effect on the first run. There's a fix coming for this. Now what we can do is that fix up task. So if we have a look at our users, as we mentioned before, yes, account get by DN, and we have a look at, so we can see that they already have MemberOf attributes. These are the ones that came over from OpenLDAP. And given that we're the directory manager, we can see that the actual hash of the password that we set, you shouldn't be able to see this as anyone else, but you can see that MemberOf is already here. But we don't know if it's completely consistent and it's exactly the way that we would have done it. You can see that the DNs are all normalized to lowercase, for example. So what we can do is with dsconf, we can actually tell the MemberOf plugin to regenerate all of these attributes in case something has gone wrong with them. So this filter says which entries we should fix up the attributes on, and then we say which scope we want this to occur in. So we run the fix up task. This is all done live where there's no restarting, none of that. A lot of things in 3.8.9, with the exception of enabling a plugin, and like a handful of other things, the majority of admin tasks can be done online and live, which is really great, especially with this kind of thing where you want to fix up this, this data. So now that that's done, if we get this user again, we can now see that the task has happened. And you can actually see here, do you see how the OU groups is capitalized? That's because we preserve the case in 3.8.9, whereas OpenLDAP normalizes it down. But again, like most applications can deal with this because DNs are case insensitive anyway. So we can see that the fix-up task has actually regenerated this data for our accounts. So now let's go and have a look at another machine. This is a second machine. It's just a different terminal tab. And we're going to set it up so that it can authenticate to our machine. Now, I've done a few things already to set this up. We've set up SSS, for example, in NS switch. But now we need to actually configure SSSD. So normally SSSD has this default config. So what we can do is, as mentioned, there's the DSIDM localhost client config. And we can see that one of the things that we can generate is a SSSD config. So we can generate that now. And what I'm going to do is is it even gives you a warning saying you should review this parameter for LDAP-I because it probably won't work remotely. So I'm going to grab this, copy it, going to edit. Okay. So we've now put in our config, and we're just going to change this to be localhost. The actual IP of the machine, I should say, 20.50. And just for now, we're not going to do TLS validation. Now, it's worth noting in your production environment, you should be using LDAP-S. LDAP-S is really the only secure transport to an LDAP system. SSSD by default, if you try to send a password, if this URL says LDAP, it'll try to do start TLS by default. But if the start TLS fails, there's a risk of the password being plain texted on the wire. So you really want to be using LDAP-S here for this communication. It's just for the interest of time. I'm not doing it. But it is quite easy to actually set up. Again, all of the steps on what you need to do in terms of putting the certs here and doing the rehashing, these things are all documented in the files. There's a lot of things here that are documented in these configs to really help you just have an easier setup process. And even stuff like, what UUIDs, account policies, and how to set up like SSH authorized keys and what commands are related. There's a lot of stuff here that's actually just really helpful and documented here. So now that we've set that up, we can start SSSD. And if we ID user 0, we can see that they now suddenly appear. And this means that our SSSD config is working. So it's really nice and simple to get started with setting up clients, setting up your data, bringing it in and enabling some of these features. The main thing is probably just that, there's a lot of room for exploration and a lot of things here. But again, we've tried to document as much as we can in the tools so that you should not need to always reach for the main manuals. There's a lot of stuff in the -- helps. There's a lot of stuff in the comments and these files that we generate. There's just a lot of things that really are there to try and help you do your job. So the takeaways from this demonstration is that there's a number of tools which are provided as part of 389, and the way that they work generally is based on what the tool is. dscreate makes a new instance, and remember there can be multiple instances on one server. dsctl performs local instance actions. This is generally the kind of action that requires you to SSH in and become root. So this is stuff like local backups, local restores, start, stop, or perhaps even removing the instance itself. dsconf is about managing the directory and the content of cn equals config. This is where you have the directory manager user, which is the LDAP root user, and you're using this to administer the content probably of cn equals config. DSIDM manages the content of a single backend or a single database, and this can be performed remotely or on the machine via CN Directory Manager or through delegated permissions that you have granted via access controls. The OpenLDAP to DS tool assists in the migration from OpenLDAP to 389 DS by automating some of the steps and giving you the checklist for you to perform. And of course, all of the LDAP search, LDAP Who Am I tools that are provided by the OpenLDAP2 client tools package are as before. And so existing LDIFs, changes, things like that, provided that they're still compatible with 389, these will still work and still be relevant for your instance. So, homework. For you, please try out the OpenLDAP to DS tool in your staging and development environments. Report what is good or what's not, and ask questions. Every question could be a bug or improvement. Reach out to our support teams, reach out to the 389 project, ask us things, and this way, the sooner that we're doing this, the sooner you're testing this in your staging and development environments, The earlier that we can help resolve any issues you may have, we may need to do some engineering to help you actually support your required use case. But again, we have that time, and it is going to take research and work from all of us in order to make these migrations as smooth as possible, so that when you do go to do that production migration, it should be a seamless and effortless process. I hope that this has helped you, and I hope that you all have a great day.